Hello students, good morning to all of you. Myself is Dr. Santosh Choudhury, editor in chemistry. And last class we discussed about, that is class number 7, method of preparation. What is halogenes? Means halogen derivative of benzene, and the nomenclature, classification, and we have to go through the type of reactions. Type of method of preparation. Last we discussed about the type of reactions, and we have to briefly explain the reactivity of halobenzene or chlorobenzene. And the halobenzenes is quite different from alkyl halide or haloalkanes, because haloalkane generally undergoes the nucleophilic substitution reaction, but the same reaction does not taking place ordinarily in case of halobenzene. There is two reasons. One reason is the halogen atom in aryl halide or halobenzene bonded to a sp2 hybridized carbon atom, and there is small difference between the sp2 hybridized carbon atom and the halogen. That's why the bond is not so polar. If not polar, the reactivity decreases. Again, the halobenzene or aryl halide can exhibit resonance. Due to the resonance, the carbon halogen bond is double bond, and to break the double bond it requires more energy as compared to carbon halogen bond in alkyl halide. Next, in aryl halide, the halogen atom possesses positive charge due to the resonance, and a positive charge species cannot be replaced by a nucleophile. That's why aryl halides are less reactive as compared to alkyl halide. Although it is a less reactive or stable, but it shows some nucleophilic substitution reaction in drastic condition. The drastic condition is when the benzene ring of alkyl halide is substituted by a nitro group, the reactivity is increases. As the number of nitro group increases, the reactivity also increases. So today we will discuss some nucleophilic substitution reactions of chlorobenzene and electrophilic substitution reactions of chlorobenzene due to presence of the benzene ring. That means due to the aromatic character of the benzene ring in chlorobenzene. And we will discuss some environmental effect of polychloroderivatives, that is your methylene dichloromethane, chloroform, iodoform, carbon tetrachloride, DDT, benzene hexachloride, so on. Okay, let us start the reactions of Arenes. That is, you are taking the example of chlorobenzene. The chlorobenzene undergoes two type of reaction. One is called nucleophilic substitution reaction, that is the Cl is replaced by the nucleophile. Another reaction is electrophilic substitution reaction. This is due to the benzene ring. Another reaction is your reaction with metal like sodium, magnesium, lithium, etc. So, the chlorobenzene undergoes nucleophilic substitution reaction under drastic condition. What do you mean this drastic condition? The drastic condition means generally you are using high temperature, high pressure and presence of catalyst. This is called the drastic condition. And under this drastic condition, the chlorine atom of chlorobenzene gets substituted by a nucleophile, very strong nucleophile, not ordinarily only nucleophile. So, what is the nucleophilic substitution reaction of chlorobenzene? Starting with chlorobenzene, starting with what? Chlorobenzene. The chlorobenzene, when treated with sodium hydroxide or distilled, or we can say distilled with sodium hydroxide at a high temperature and high pressure, this chlorine atom undergoes the substitution. That means this can be substituted by the what group? OH group. So this is formed sodium phenoxide. This is treated with dilute HCl. It gives you phenol. This is called sodium phenoxide, and this is called what? Phenol. You see, the Cl group is substituted by OH group. Then this is one of the method of preparation of phenol from chlorobenzene. And this process is called dose process. What is the name of this process? It's called dose process. What is dose process? In dose process, we can synthesize the phenol or prepare the phenol from chlorobenzene by the action of sodium hydroxide at high temperature and high pressure. This is one of the nucleophilic substitution reaction of chlorobenzene. The chlorine atom of chlorobenzene gets substituted by the OH group. That is the nucleophile OH group. Okay, student, you learned here how can you convert the chlorobenzene to phenol, or we can also convert benzene to phenol. How can you convert the benzene to phenol? The benzene first convert to chlorobenzene by chlorination, and then the chlorobenzene convert to phenol by dose process. Okay, students, now if the chlorobenzene is treated with aqueous solution of ammonia in presence of CO2, which upon heating at high pressure, what happens? This chlorine atom is substituted by NH2 group. So this will form aniline. This from what? Aniline plus HCl. This is also a one type of nucleophilic substitution reaction. The chlorine atom of chlorobenzene is substituted by a nucleophile NH2 minus. Okay, students, and this can also be undergoes nucleophilic substitution reaction when this chlorobenzene treated with a strong base, that is NaNH2 sodamide, sodium amide. So it is a strong base. This can be easily substituted to form aniline. Okay, students, these are the some nucleophilic substitution reaction of chlorobenzene. The chlorobenzene shows nucleophilic substitution reaction under drastic condition. Means some abnormal condition, a particular high temperature, high pressure, and in presence of the catalyst. Okay. Next, we discuss about the electrophilic substitution reaction. That is where it undergoes electrophilic substitution reaction. What is this electrophilic substitution reaction? The electrophilic substitution reaction means the hydrogen atom of benzene, nucleus of chlorobenzene, this is your chlorobenzene. Now this hydrogen atom of any hydrogen atom, we contain this is CH, this is CH, this is CH, this is CH, this is CH. And this hydrogen atom gets substituted by an electrophile, that is minus H plus ion, that is substituted by a electrophile. It gives the electrophilic substitution product. So the electrophilic substitution reaction are shown due to the aromatic nature of the benzene ring. The electrophilic substitution reactions are nitration, halogenation, sulfonation, and Fidelkraft's reaction. Do you know this reaction already we have discussed in last year, that is in first year in benzene chapter. Okay, like benzene, it undergoes nitration, halogenation, sulfonation, and Fidelkraft reaction. In nitration, the electrophile is NO2 plus. In halogenation, the electrophile is X plus. Sulfonation, the electrophile is SO3. And in Fidelkraft reaction, the electrophile, these are what? Electrophile, the electrophile is R plus or RCO plus. Next question arises, in which position the chlorobenzene undergoes electrophilic substitution reaction? So, you see, suppose you are taking the chlorobenzene. The chlorobenzene can exhibit resonance structure, and due to resonance structure, it can give the different resonating structures. and another resonance structure. And another resonance structure. So you see, due to resonance, the negative charge possessed by the benzene ring at ortho position and para position. Do you know what is ortho position, what is para position? This is the chlorobenzene monosubstituted. Chlorine is substituted here with respect to this one, nearby two position. This position means this is your chlorobenzene and these two are ortho position. And this is your meta. And this is your para. This is again ortho. And this is again meta. So with respect to the chlorine atom, the benzene nucleus have two ortho position, two meta position and one para position. You see, in due to resonance, the negative charge possessed at ortho position as well as at para position. So the nucleophile, what is nucleophile? The E plus is your E plus is your electrophile. The electrophile must be substituted either ortho position or at the what position? Para position. Not any other position, not in meta position. That's why we can say in chlorobenzene Cl is the OP directing group. Means the next electrophile is substituted as ortho para position. You know, generally the ortho para directing group are activated group. Means it activates to facilitate to attack this nucleophile at ortho and para position. But in case of chlorobenzene, Cl group is a deactivating group due to more electronegativity of chlorine. Are you clear? Again, generally ortho para directing group are the activating groups. Means activating means due to the presence of ortho radiating group, the benzene ring possesses negative charge at their ortho position or the what? Para position. But in case of chlorobenzene, it is a deactivating group because there is a large difference between electronegative difference between chlorine and carbon atom. That's why the group is not activated, it is a deactivating group. That means generally the chlorobenzene does not undergoes nuclear substitution reaction, not the electrophile substitution reaction. That's why generally chlorobenzene are considered as a inert solvent, although presence of carbon, chlorine. Okay, students. So in electrophilic substitution reaction, always you will getting the two product. One is meta substituted product. One is ortho substituted product, while other is para substituted product. Let us consider the electrophilic substitution reaction of chlorobenzene 1 by 1. So you take the chlorobenzene. When this chlorobenzene undergoes the electrophilic substitution reaction, when treated with chlorine in presence of anhydrous ferric chloride, the chlorine furnishes the chloronium ion, Cl plus ion. This Cl plus ion substituted the ortho and para position. And one isomer is ortho isomer, another isomer is para isomer, and this another molecule gives Cl. And this one is known as para dichlorobenzene, and this one is called ortho dichlorobenzene. Okay, and out of these two substituted products, this is somewhat major and this is somewhat minor. That means this gives more amount of field, that gives less amount of yield. Okay, this is called your what process? This is called your chlorination. This is called what? Chlorination. That is the hydrogen atom of benzene, nucleus of chlorobenzene, is substituted by what? Chlorine atom. Suppose this one treated with concentrated HNO3 and H2SO4, concentrated H2SO4. You work with this. It gives a nitro compound, that is, it gives a mixture of the two products. And this is para nitro chlorobenzene, and this is ortho nitro chlorobenzene. And this process is called nitration. Okay, students, this is all are the electrophilic substitution reaction. Similarly, when the chlorobenzene treated with sulfur trioxide and concentrated sulfuric acid, or you can treat it with fuming sulfuric acid, that means this phenyl H2O7, that's called oleum. That is, fuming sulfuric acid means the sulfur trioxide gas dissolved in concentrated sulfuric acid. What is that one? Fuming sulfuric acid means the sulfur trioxide gas dissolved in the concentrated sulfuric acid. That means it gives a fumes of sulfur trioxide, and that one gives you H2O3, and this is called oleum. When chlorobenzene treated the oleum and one koriba, then it gives the mixture of ortho and para derivative, and this one is called para chlorobenzene sulfonic acid. This one is called para chlorobenzene sulfonic acid, and this is called orthochlorobenzene sulfonic acid. And this process is called what? This is known as your sulfonation. This is known as what? Sulfonation. Okay, these are the electrically substitution reactions of chlorobenzene. Again, this is another one more electric substitution reaction is Friedel-Crafts reaction. So chlorobenzene treated with suppose Rx in presence of ferric chloride and hydrous ferric chloride. The hydrogen atom of benzene nucleus is substituted by the electrophile R plus. So it gives a mixture of and this is called parachloro alkyl benzene, and this is called orthochloro alkyl benzene, and this reaction is called Friedel-Crafts alkylation. It's called what? Friedel-Crafts alkylation. For example, if you take the chlorobenzene treated with methyl bromide in presence of anhydrous ferric chloride, what product will get? The R means here CH3 group, and the CH3 group is substituted in ortho and para position, that gives you Cl. Here is CH3. This is here gives you para chloro toluene or para chloromethyl benzene plus orthochlorotoluene or orthochloromethyl benzene. Okay, student, this is called Friedel-Crafts alkylation because the alkyl group is substituted in the benzene ring, and another Friedel-Crafts reaction is acylation. Means the chlorobenzene undergoes Friedel-Crafts acylation. So the chlorobenzene is now treated with acid chloride in presence of anhydrous ferric chloride, and the hydrogen atom at ortho and para position substituted by a acyl group. What is this acyl group? RCO plus is called acyl group. It is one of the electrophile, and this electrophile is substituted at ortho position. That means it give a one type of aryl ketones. You see, this is keto group. Sure. And para position, ortho position. So suppose you take the chlorobenzene treated with CH3COCl in presence of anhydrous ferric chloride. What will give? It will gives you Cl here. What is substituted here? Is substituted COCH3. And this one is called acetophenone. If you not chlorine, then simply call acetophenone means CH3CO phenyl group C6H5. But this is called parachloro acetophenone. phenol. And give another isomer. The another isomer is orthochloroacetophenol. Okay, students, these are this reaction is called Fidelkraft acylation, because a acyl group is substituted in the benzene ring of chlorobenzene, either ortho position or para position. And you just to remember how the chlorobenzene get converted into different class of aromatic compound. The chlorobenzene convert to phenol, chlorobenzene convert to aniline, chlorobenzene convert to parachlorotoluene. So many reactions are there. Okay, students. Next, come to these are the reactions of nuclear substitution reaction as well as electrolyte substitution reaction. Next, come to reaction with metal. So, in reaction with metal, first come to the reaction of metal means a sodium. So, chlorobenzene react with 2 atoms of sodium. That is 2 molecules of chlorobenzene react with metallic sodium. You heat this and warm it in dry ether. Just like a Choudhury reaction, in case of alkyl halide or halohgen, it gives a higher alkane, that is called Choudhury reaction. Here also same type reaction, it gives this one. It will come to this is one phenyl group, this is another phenyl group, which is called biphenyl. What compound you will get? You will get a biphenyl, means the 2 benzene rings are connected to one another. That is called biphenyl. And that reaction is known as Choudhury reaction in case of aliphatic alkyl halide. But here the reaction is not Choudhury reaction. It is simply, this is known as phytic reaction. What reaction? Phytic reaction. That is called Choudhury reaction. Suppose when the Choudhury reaction and phytic reactions components, that is in Choudhury reaction the reagent is alkyl halides, and phytic reaction the reagent is chlorobenzene. If you take alkyl halide and chlorobenzene, you heat it with sodium, metallic sodium in dry ether, it give a alkyl benzene, and that is the reaction is called Choudhury-phytic reaction. What reaction is called? Choudhury-phytic reaction. A part is Choudhury reaction, a part is phytic reaction. So, suppose you take chlorobenzene, react with metallic sodium. In case of chloromethane, you heat in presence of dry ether, and this get lost molecule of NaCl. This gives you toluene, or you can say ethyl benzene plus 2NaCl. And this reaction, this is called phytic reaction. This reaction is called Choudhury-phytic reaction. Okay, students, are you clear? What is fatigue reaction? What is Wurtz fatigue reaction? The difference between fatigue reaction and Wurtz fatigue reaction. In fatigue reaction, the alkyl halide is chlorobenzene, but in Wurtz fatigue reaction, chlorobenzene plus alkyl halide. Next, come to suppose you take iodobenzene. What is iodobenzene? This is your iodobenzene, and you take the two molecules of iodobenzene heated with metallic silver powder, or metallic copper powder. Copper powder, when you heat this in dry ether medium, this get lost CuI. This same compound will form the diphenyl. This is called biphenyl plus CuI. So it is no doubt it is a just like your fatigue reaction. In fatigue reaction we are using what? Sodium, but in this reaction we are using copper. So this is somewhat other name of reaction is called Ullmann's reaction. Ullmann's reaction. Okay, students, these are the reactions of chlorobenzene with sodium. The chlorobenzene can react with magnesium, or you take bromobenzene. It reacts with magnesium in dry ether, result to form phenyl magnesium bromide. And you know, alkyl magnesium bromide is known as Grignard's reagent. Like that one, this is I'll say one type of Grignard reagent, phenyl magnesium bromide, and it is used for the preparation of various class of aromatic compounds. Okay, students, these are the reaction of chlorobenzene with metal, and this is all about the reactions of chlorobenzene or haloarenes. So the haloarenes can undergo nucleophilic substitution reaction, electrophilic substitution reaction, as well as reaction with the metal. Okay, students, next we will discuss today the environmental effects and uses of some polyhalogen derivative of alkane. Polyhalogen derivative of alkane. What do I mean by poly? What do you mean this poly? Poly means many. Many means more than one halogen per molecule. Poly means more than one hydrogen, more than one halogen per molecule is called polyhalogen derivative. So the polyhalogen derivatives are dihalogen derivative, trihalogen derivative. So you can also tetrahalogen derivative. Dihalogen derivative means 2 halogen atom per molecule and 3 halogen atom per molecule, and tetrahalogen means 4 halogen atom per molecule. In this way you can write. So the dihalogen derivative again 2 times. One is called geminal and is called vicinal. Geminal means the 2 halogen atom possessed by the same carbon atom. That's called geminal. Vicinal means the 2 halogen atom are in conjugative carbons. You see what is the difference? The difference is the 2 halogen bonded same carbon atom. But in this case, the 2 halogen atom bonded to conjugative carbon atom. And these are the 2 types of dihalogen derivative. If the dihalogen derivative not geminal, not vicinal, if it other than this, then it is called terminal. It is called what? Terminal. Okay. Similarly, the trihalogen derivative means 3 halogen atom per molecule, and this is called, in case of methane, it can haloform. In case of methane, this is called haloform. Haloform means suppose CH, CH3, CH, Br3, CH, I3. And this one is called chloroform. This is called bromoform, and this is called iodoform. That is, trihalogen derivative of methane is known as haloform. When the halogen is chlorine, then you can say it is chloroform. If it is bromine, that's called bromoform. If it is iodine, iodoform. Okay, student. Similarly, when you say tetrahalogen derivative means particularly CCl4, not CBr3, Br4 or CI3, because higher halogens large in atomic size, they are unstable, and this is one of the most stable compound, and this is called carbon tetrachloride. And this is known as pyrene. It's called what? Pyrene. So these are the polyhalogen chloroderivatives of alkane, and what are the uses and environmental effect on environmental effect and air also human. So now come to the CH2Cl2. This is called dichloromethane, and it is generally in laboratory very popular, known as DCM. Known as what? DCM. And the method of preparation not included in your course, but what is the uses, environmental effect? That is, if the vapors lies or presence in the atmosphere in air, that is low concentration, it will become slightly impaired in hearing as well as vision. But at high concentration, they affect the dizziness. That means enditi manda lagibo, dizziness also lagibo. And another is nuisance of the finger, anguli enditi monka hijibo, and nausea. These are the environmental effects. And the direct, when the DCM come to your contact to your skin, it gives irritating and burning. Okay, it is the uses. The uses is, it is used as a solvent, particularly when the component of the mixture separated by the process is called your solvents extraction. In solvent extraction, you are using a solvent, a organic solvent, and a polar solvent, and a organic solvent and a aqueous solvent. The aqueous solvent part is your DC. And this solvent extraction method used for the separation of different components, particularly in your synthesis of organic compound or in pharmaceutical industry. And it is also used, that DCM also used as paint remover. You know, thinner, you know what is the thinner? You are adding the paint to make it thick. The thinner is used as and the DCM used as a thinner. And it is propellant in your air source. Propellant means it will carry out. It can carry the different reagent in the air, that is propellant air source. Okay, this is the about your DCM. DCM means dichloromethane. Next comes another compound that is called trichloro derivative of methane, that is CHCl3. This is called chloroform. And the chloroform has a characteristics order, and the exposed to the chloroform that is for a long term, meaning by exposed to chloroform, chronic means for a long time, it causes cancer. It damages your kidney, it damages your cancer. That's why this is called a one type of carcinogenic. And inhaling the vapor of chloroform, it can affect your central nervous system. In older time, during the operation, they are using some anesthetic, means to make the cell unconscious. So chloroform vapor, again, if you inhale the chloroform vapor, you can become senseless. Okay, because this will affect on the central nervous system. Next, in presence, if the chloroform vapor presents in the air, it makes us dizziness, fatigue, and causes headache. And what the use of this chloroform? The main use of chloroform to prepare freons. What is freons? Freons are chlorofluorocarbon. That is CFC. And the fluorochlorocarbon can be prepared from chloroform by Schwarz reaction. Swart reaction is one type of halogen exchange reaction. You take the chloroform, you treat it with AgF. It can form fluorochlorocarbon. So that's why it is used for the preparation of freons, and it is also used as a solvent, and it is used in case of making cough syrup. And during coughing you are using the cough syrup because that medicine that is dissolved in your chloroform. Next come to iodoform. You know what is iodoform? The iodoform is CH I3, and it is unstable and liberate iodine. That's why this is used as a antiseptic and used for dressing your wounds. And this is also used to making the manufacture pharmaceutical lines. Then you come to it has no environmental effect. Next come to carbon tetrachloride. That is carbon tetrachloride is commercially known as pyrene, and the carbon tetrachloride is environmentally effect. It can depletion of ozone layer. You know, in stratosphere there is a layers of ozone which cover the earth just like an umbrella from ultraviolet ray, sun ray, ultraviolet ray from the sun. And the ozone layer is a filter the ultraviolet radiation, UV radiation to visible radiation, but any trace of quantity present in our atmosphere that can destroy the ozone layer or depletion the ozone layer, and it can permanently damage the nerve system because it is little bit unreactive. It can deposit it, not react with any other component, and it can affect up the metabolic process. Okay, so it is particularly used for the preparation of freons and also organic solvent. Okay, next we come to what is freon. Freons are nothing but fluorochlorocarbons, and the fluorochlorocarbons are used as a this called freon 1,2 refrigerant. It is used as a refrigerant, means a cooling agent what you are used in your refrigerator as well in AC air conditioner. But it is very harmful to your ozone layer. Next come to another one is your polyhydric compound is your DDT. Do you know what is DDT? This is called dichloro diphenyl trichloromethane. In fact, in class number 1 in first class I draw the structure. The structure is Cl. A phenyl group means a benzene ring is there, which bonded to a carbon atom, and this is your CCl3. This is called dichloro, diphenyl, trichloroethane. After Second World War, DDT is very much famous, particularly DDT is used to control the malaria. Means it can liberate chlorine, and the liberated chlorine can destroy the larva of malaria parasites. But it has a toxic effect to the fish. And the malaria parasite mosquito can resist now this DDT. That's why in USA, in some other developed country, they ban this. But till it is you are using in our India, Sri Lanka, Bangladesh, so many countries. Because these areas are what? Malaria parasites. And it is a effect to the what? Effect to the environment. It is a non-biodegradable pollutant. What is non-biodegradable pollutant? Means it cannot mix in the environment. What is biodegradable? Biodegradable, suppose you throw a piece of paper, after a few days, after 1 month, the paper get hydrolyzed or get react with the soil or microorganism of the soil, it get destroyed, it get mixed with your soil. That is called biodegradable. But what about this? It is non-biodegradable. That's why it is banned. And it is the and when it gets consumed by the animals or fishes, it is not metabolized. What is metabolized? Means it is not digested. It is not mixed in our food. It gets deposited in the fatty tissues, which will causes or damage that one. So these are the uses. Okay, students, these are the some uses of polyhalogen derivative of alkanes. And all about this chapter or this unit, we can say in this unit I study the halohalkanes, haloarenes, their method of preparation, and you will learn a much more thing how a given compound is converted to alkyl halide, and alkyl halide compound get converted another one. Now go to your book. Any book, you may go to college application books or a modern college chemistry book or any other books, and try to solve the questions at the end of the chapter. In your doubt class, we will discuss any doubt and go through. Okay, student, this much today.